Okay, so here we are again, doing a lesson, cross-country attire, just like yesterday, and maybe hopefully we'll have our meet today. But I want to talk about another section in 2.4, position, velocity, and acceleration. And again, depending on your physics background and your science background, maybe this is going to seem super familiar to last year's physics. Some of you might be brand new, and maybe you were hoping to go through high school without even having physics. Too bad, you're in BC Cal, you're going to get physics. But this is very, very elementary compared to maybe if you're taking AP Physics or Physics C. And a lot of this is simplified just to show that what is the application that calculus can play in physics. And so PVA, position, velocity, and acceleration, because we've already kind of even touched upon this. Like if you have a function that analyzes position and you want to know what's that instantaneous change of position at a particular time, that's velocity. And so the change of position over time could be measured as velocity. And then similarly, if you want to measure the change of velocity over time, that's acceleration. So we're going to associate position functions, velocity functions, and acceleration functions with just normal function derivative as a first derivative and then a second derivative. Okay, and some of these examples are going to be very quote-unquote elementary, just again start showing some of that application. So here's one example. Like I give you a function and I give you velocity, and I think that's key here too. And I know I'm going to highlight this because I enjoy that. But like really stress that like you have to know what is it that you're looking at, whether it's algebraically or graphically. Are you looking at the position, or are you looking at the velocity, or are you looking at the acceleration? Because no matter which of those three lenses you're looking at, you will be required to know something about the other two. So this is velocity. I'm telling you for the first 10 seconds, 10 units of time, this equation right here represents its velocity at any given time, t. Now, we know enough calculus, and we could have easily derived this. There is a product rule, there is a chain rule. We could take the derivative of velocity to measure its instantaneous rate of change, and then regroup and factor to get an acceleration function. You might have to do that in some of the exercises. I've done it for you. So here's velocity over time, velocity and acceleration with respect to time. Now, this isn't the only way to do this, but I like to draw a sign chart to analyze this, to really pinpoint some of the next questions. So that's why I sort of said this, let's have this be our first part. So I rewrote what the velocity equation was and what the acceleration was. And again, trying to expedite the process here, I've already factored it for you. A lot of times you're going to have to do the factoring. And so it's for the first 10 seconds, our concern is when is this zero, so we can match signs, whether it's positive or negative. So we know the velocity turns at 0 at t equals 2, and then also at t equals 4. And then key points here are critical values for acceleration, still 2, but then also 10/3. So I'm going to put a 2 here. And then 10/3, well, 9/3 would have been exactly 3. 12/3 is 4, so 10/3 is before, if these are lined up. So 10/3 is like right about there. So t equals 10/3. Okay. Now, I want to draw a sign chart. And like you could test values in each of the regions, which I usually start with, but I also am going to use the multiplicity of these exponents. That if you have a even multiplicity, if it's 2, 4, 6, 8, then the behavior on either side of that is going to be the same behavior, either both positive or both negative. If your multiplicity, that factor gives you, if it's odd, then it has to change signs. And it's interesting because I'm teaching this right now in honors pre-calc, this idea of multiplicity and how you could have it as a polynomial or a rational function, and the behavior of the intercept or the behavior of the asymptote will be determined based on the multiplicity, right? The degree of those factors. So if we initially start off with velocity 0 or 1, you put it in here, this is always a positive value. This is negative, so the product of a positive and negative becomes negative. Now, I don't necessarily have to test a point. If I know that at t equals 2, its multiplicity was even, so the sign of this has to match. If you're not sure, try 3, still positive, negative, the product is negative. And then t equals 4, that's still positive, that's positive, so the product is positive. And velocity is a signed value. It's a vector. It has a magnitude but also has a direction, positive versus negative. And if you feel a little bit like you need some brushing up on your physics or some of the terminology, in your workbook, I think page 37, I give you a summary sheet. So I define what is displacement and what is velocity and what is acceleration and things like that. Yeah, page 37. So in your workbook, look at page 37 as a great reference. It's not homework, but it does have some worked out examples. Okay, now, where am I at there? Okay, I'm going to do a similar thing with acceleration. Choose blue, why not? So for acceleration, again, putting it in here, now notice each of these multiplicities are a 1, so it's odd degree. That means as soon as you found one region, everything has to alternate because of the multiplicity of your 0. So you could do a test point of 1 and know that this will be negative, this will be negative, so the product is positive. And after that, I don't need to test any more points. This has to change signs, and then this becomes positive. Okay, so I have a nice visualization of what direction velocity and acceleration are. And remember, velocity as a signed value, if it's negative velocity, we're gonna associate with either moving to the left or down, positive velocity to the right or up in that direction. And a lot of these we're just looking at a linear motion. So it's one like either like horizontally or just vertically. We're not going to break it up into multiple components. Okay, now how do you interpret this? This means you're moving to the left. It doesn't mean you're slowing down. Negative velocity does not mean you're slowing down. It means you're moving to the left. You're moving to the left. Positive velocity doesn't mean you're speeding up. It means you're moving to the right. How do you know if you're slowing down or speeding up? Right? Like that's the very first question. Like, is it slowing down or speeding up or stopped at 2.5? Justify your answer. So you need to look at that 2.5 seconds. At 2.5 is here. Okay? So I have negative velocity and negative acceleration. If your signs match, both negative, or it could be both positive, right? But if they are both negative, you're still speeding up. You're just speeding up in the left direction or the down direction. If signs are both positive, you're still speeding up, but you're speeding up in the right or the up in the positive direction. Okay? The only time you're slowing down is if the two signs don't match. So if I have one negative and one positive, I'm slowing down. If I have one, doesn't look like, so it's negative, positive, negative, negative. There's another region, negative, positive. I'm slowing down. If the signs are opposite each other, they're kind of like opposing forces, you're slowing down. Now, in which direction are you slowing down? It's all based on velocity, right? Velocity determines which way you're going. So like I could think about, okay, negative velocity, I'm moving to the left, positive acceleration, an opposing force. I'm slowing down. In what direction am I slowing down? To the left. Now at time equals 2, notice that my velocity is for that moment 0, and then all of a sudden it's still negative velocity, but now I have negative acceleration. So I'm getting more negative with my velocity. In other words, I'm going faster in that direction. I'm going faster in the left. Then at some point, I'm still moving left, but at t equals 10/3, now I start slowing down towards that left because my signs don't match. And then at time equals 4, my velocity for that moment was 0, and then all of a sudden they match, so I'm speeding to the right. So you've got to imagine that there's just a particle moving along the x-axis. I mean, this is all that's happening. Here's what we're describing, and maybe I should have even quantified that at the beginning. Like all that's happening is a particle is moving back and forth, and you're analyzing its motion. Is it slowing down more towards this, speeding up this direction, speeding up in that direction, slowing down in that direction? All you're doing is breaking it down, moving along the x-axis. So it sort of makes sense that like if I'm moving left and I need then to move right, I better slow down before I go in the other direction. I have to slow down. So notice in this interval here, you can even like highlight it. Why not? Right? In this slice of time right there, I'm slowing down because my signs don't match. I'm also slowing down here. I start slowing down to the left. Okay, so t equals 2.5. We have negative velocity, negative acceleration. So now we can finally answer this question. Is it speeding up, slowing down, or stop? Just to find. So we have to answer the question. It's speeding up. And then how do I know? I could say both a of t and v of t are positive, are greater than 0 at t equals 2.5. So not only is it speeding up, oh, I'm sorry, not positive. See, even tapes, I make mistakes. I get crazy, excited about this. They're both negative, okay? But they're the same sign. Both a of t and v of t are negative. They're the same sign. Therefore, I know it has to be speeding up, okay? And in fact, because it's a negative velocity, it's speeding up in the direction of that's left, okay? Now, how many times does a particle change direction? So kind of going back to that model of this just moving along the x-axis, right? To change directions for an instant, you first have to have 0 velocity. Okay, so I could be going here, stop, and then turn around and go back that way. But the thing is, just because I'm stopped, it doesn't mean I've turned around. I could go here, stop, keep going this direction, stop, keep going in this direction, stop. So being 0 is not good enough, and that's one of my favorite phrases to say, because it kind of sounds like, oh, being 0, it's not good enough. Be more, like literally. You can't just be 0. Not only do you have to start at 0, but then you have to actually change signs. Go from a positive to a negative. So if I think about, I'm negative, 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 I'm 0 for an instant, but I'm still more negative. So that 0 wasn't good enough. But here, I'm 0, and I change from negative to positive. So there's definitely a direction change there. And that was at t equals 4. So there is only one time, and that's t equals 4. And if you go back and look algebraically at the zeros, do you notice that the multiplicity again of this 0 is even? It didn't change signs. It bounced on the graph. It kept whatever sign it was. This is odd. So if your factor is odd, you know you'll have to change signs. Okay? And then it says, for what values of t are you slowing down to the right? Okay, so first of all, I'm moving to the right. That tells me if I'm moving to the right, my velocity, v of t, better be positive. It better be greater than 0, because that determines direction. Okay? To slow down, I have to have an opposite sign. I have to have an opposing sign. So if my velocity is positive, my acceleration better be negative. So I'm looking for positive velocity, negative acceleration. So do we have positive velocity with negative acceleration? Positive velocity is here, but notice there's no negative acceleration. So there are no times is this slowing down to the right. The only time it's moving to the right is actually speeding up. It's slowing down to the left, but not slowing down to the right. So then to answer this question, for what values? None. Okay, there are none. At no time will these two things happen. Will the velocity be positive while your acceleration is negative? Okay, so I'm going to pause this video because I know we've gone for about maybe 13, 14 minutes. And then I'll start doing example 2 where you're looking at graphs. And one of them will be a position graph, one will be a velocity graph.